Hi guys, welcome back. We're going to cover section B today and talk about the moon. So the moon is something that we see all the time. It provides us some light at nighttime. It is considered a satellite. A satellite is anything that orbits around something else. So it's a natural satellite of the Earth. It's actually the only natural satellite of our Earth. And that is a picture of the moon. I actually took that picture of the moon on it was like a super moon. It was really bright and somewhat closer to the Earth. And it's actually through my telescope. The moon does not create any of its own light. It only reflects the light of the sun. So in a full moon, it's in full, view of the sun. We're going to talk about the phases of the moon at a later section, why it is that it's not always full, okay? And it's not because the Earth is blocking the sunlight, okay? It is a lot smaller than the Earth, certainly a lot smaller than the sun. The diameter is only 3,474 kilometers, whereas the Earth's diameter is more than 12,000 kilometers, okay? It is much closer than the sun as well. It's 238,900 miles away. Now, it's really cool that if you think about it, the moon and the sun look like they're the same size in the sky, okay? And you don't see them at the same time very often. Sometimes the moon is visible during the day. But the reason we can have a lunar eclipse is the moon can actually completely a solar eclipse. The moon can completely cover the sun. They are the same size in the sky, even though they're super different in actual size. Their perspective is equal based on the distance of the moon. It makes it look much smaller, and they're kind of the same size. I think that's how God designed it for us. Anyway, because the moon is smaller, it has less gravity. It has about 1/6 of the gravity that we have here on Earth. Okay, so the moon's structure is actually quite similar to the Earth. It has a core, it has a mantle, and it has a crust, and it even has moon quakes. Okay, so that seismic activity is what has allowed scientists to come up with this prediction of what the composition of the moon is, and they think it's similar to the Earth. So it probably has a solid inner core, just like Earth, surrounded by a liquid outer core. The mantle is very similar to the Earth's, but a much higher content of iron, and then a thin crust around it. Now, it's not necessarily cut into plates like the Earth is, okay? And another difference is that there's no atmosphere, virtually no atmosphere. So nothing's getting trapped within the surface of the moon, no gases, okay? And it also has a very weak magnetic field, so it's not protected like the Earth is, okay? The surface of the moon is very unique, okay? It's covered with craters, and part of the reason for that is because of the lack of atmosphere. We get hit with asteroids and meteors here on Earth, but a lot of them burn up because of the friction of the atmosphere, okay? So the moon is covered with craters from all these different meteoroids and asteroids, and you can actually kind of detect some of those with the naked eye. The different colorations that you see on a full moon, some of those are actually from the craters, okay? Some craters are big enough, or the meteor or the asteroid that hit the moon was big enough that you can actually see these kind of rays coming out, these brighter lines coming out from the craters. And it's just material from the moon that just basically exploded outward and it left these streaks behind, okay? The darker spots are called seas. They're actually called mares, which is plural for Maria, which means sea, okay? The Sea of Tranquility right here is where one of the first, I think the first Apollo mission landed, the first group to land on the moon. These are very flat sections, okay? And they were probably formed by gigantic impact sites where magma actually bubbled up to the surface and flooded the region, and it left this smooth layer of basalt behind, okay? And that's why it's a little bit darker than the surrounding regions as well. We also have mountains on the moon, mountain ranges, okay? Some are formed by moonquakes, so seismic activity, but most of them are probably formed by the impact of stuff from space, okay? So if there's a huge impact, material is going to kind of move out away from that area. And so some of that impact sites, some of those rims that form actually will build up mountain ranges, okay? There's also extinct volcanoes on the surface. And in some of those volcanoes, you don't see an actual crater, you see a dome. You see like what looks like the mantle pushing out of the volcano. So some of the structure is domes. These long, narrow valleys called riles, and there's different types of them, but basically they're just kind of low spots that are the edges of these impact zones. Okay, so the craters are a certain size of asteroid and meteorite, but sometimes there's these huge craters that or these huge impact sites that will just really change the surface of the moon, and kind of the edge of those can make these valleys. The surface is pretty much unchanging unless it gets hit by something. Okay, there's no atmosphere to break things up, but there's no weather either, and so there's no wind or rain or other things that cause weathering to change the surface structure. So once something is shaped, it pretty much stays there until it gets hit by something else. Okay, that's it for the moon. We'll talk more about it later. Bye.